Hey, good morning, class. Welcome back to another episode of Math 1 Distance Learning. So we've been working on translating expressions, right? We've been working on translating written sentences into mathematical expressions that include numbers, variables, symbols. And when we've been practicing going from the written words into variables, numbers, and symbols. And we've also worked going the other direction, numbers, variables, and symbols, and writing that into written words. So in today's lesson, we're going to go one step further. We're going to be translating written words, little mini stories, and we're going to translate them into full equations. So not just expressions, but full equations with equal signs, and then we're going to solve those equations. So let's go ahead and get started here. You should have the handouts and you can follow along. I'm going to flip over to my DocuCam. So hopefully you guys are having a great day, and here we go. Okay, so this lesson is called Interpreting Math Stories. This is worksheet 1, and then there's also a worksheet 2 that's a part of this lesson. So math stories number 1, translating, interpreting. Okay, so what we're going to do is we're going to continue with our pictorial representations. And we want to draw a pictorial representation to match the story. And then we want to go ahead and solve the algebraic equation. Okay, so here we go. Let's start with number 1. So on number 1, it says a dad gave his daughter some money. So we don't know how much money, so that's an unknown. He then took $50 away from her for not doing her chores. She ended up with $16. Okay, so we want to take this little mini story and we want to translate that into an expression. So he gave her some money. So that means she was receiving money, but we don't know how much. So we're going to put our little tile with a question mark. So you've seen me use this. So our little tile, and then minus $50. So he took $50 away. And then she ended up, so this would be kind of code for equals 16. Okay, so here's our pictorial representation. An unknown amount in a tile minus the 50 equals 16. So now when we translate this into algebra, all we need to do is replace the tile with a variable. And now if we want to figure out how much she originally started with, how much her dad originally gave her, then we want to add 50 to both sides. And now these would cancel. And we have 16 plus 50, which comes out to $66. So the father or her dad originally gave her $66. Okay, all right, let's try the next one. Number 2, a dad gave his daughter Emma $50. She spent some money at the mall. She now has $6 left. Okay, so similar to problem 1, the dad gave the daughter Emma $50. So in problem number 1, we don't know how much he gave his daughter. But here we know that he gave her $50. And then she spent some money. So this would be, if she's spending, this would be a negative concept or a minus, but we don't know how much she spent. And then now she has $6 left. So this would kind of be what it's equal to. Okay, so we're going to start off with 50 and then minus, but we don't know how much. So we're going to use a question mark tile. And then she has $6 left over. So now if we translate this to algebra, we're going to replace the question mark tile with a variable. And we have 50 minus x is equal to $6. So now if we want to figure out how much this is algebraically, you could do it just simple common sense in your head. You could do 50 minus how much is going to be $6 left over. But if we wanted to solve it algebraically, we would subtract 50 from both sides. So these cancel. We're going to have negative x is equal to 6 minus 50 would be negative 44. But when we're solving equations, remember, we can't have our variable in our final answer with a negative. So to get rid of this negative, this is really like a negative 1. So we want to divide both sides by negative 1. So these negatives changed this to a positive, and then these changed to a positive. So she actually wound up with $44. Now, another way that you could do it might be a little bit more confusing, but you could have originally written your pictorial representation. You could have said she had $50 and then plus and then a negative tile because we don't know how much she spent. Okay, but this probably makes more sense here. 50 minus a certain amount of money. We don't know. Okay, let's go ahead and try number 3. Okay, so on number 3, it says 8 less than twice the sum of 4 and a number is the same as 19. Okay, so the first thing that I notice is I notice that we have one of those special combo words here. So less than is a combo word. So that tells me that this is a subtraction concept, but 8 is going to get moved to the back of the expression because it's 8 less than. And we've learned that the less than special combo moves the first number to the back. Then we've got this word twice. We've already learned that that means times 2. So we're going to multiply something times 2. And what is it we're multiplying? Twice the sum. So here's one of our VIP, private party words. And so who's at this private party? It always are the 2 items that come after the word of. So sum of, and it would be 4 and a number is the same as, and then this is code for, is the same as, that's code for equals 19. So if we were to go one step at a time here, we would know that we're going to wind up with an equals 19. So I'm kind of working backwards here. So is the same as, we know that our equation is going to equal 19. All right, so now 8 less than, so we know that that's going to go to the back of something. But let's go to this VIP word right here. So the sum of 4 and a number. So we have a private party of 4 and a number. So 4 plus a number. So we need a variable. And so remember, we said that the 8 less than is going to go to the back of something. So our private party is going to be 4 and a number. And then we want to multiply by 2. So here I'm showing that the 8 is going to go to the back. Okay, so now when we drop down, we've got, here's our 8 is now at the back. It's a minus. Here's our private party, the sum of 4 and a number. And then we forgot to do the twice. So we need to go ahead and put that in there. So now I have added, or I've included, not added, but included the 2. So twice the sum, twice the private party. So twice the private party. Okay, so now we have to solve it. Okay, so here we go. So we got the distributive property of boom chicka boom, right? So this is going to be 2 times 4 is 8, and 2 times x is 2x. And then we've got this minus 8 equals 19. Now, before we start adding 8 to both sides, we need to combine like terms. And this 8 minus this 8, those cancel each other. So now we're left with 2x equals 19. And we want to isolate our variable, get the x by itself. So I'm going to divide both sides by 2. Now you might be thinking to yourself, well, okay, maybe I have the wrong answer because 2 doesn't go into 19. But remember, we're in high school now, and this is okay. So remember my rule. If these 2 numbers don't want to play nicely, if this one doesn't want to go into that nice and evenly, then it's okay. We just leave them. We leave them alone, right? So if you got someone that doesn't want to play nice, you just leave it alone. So x is equal to 19 over 2 would be our final answer there, okay? All right, let's try number 4. So on number 4, it says the difference of 6 and a number, the difference of 6 and a number, all divided by 9 is equal to 5. Okay, so we know that we've got an is equal to 5. So somewhere we're going to have equals 5. And that's going to be at the back. Okay, so we know that for sure. Is equal to 5. Now I see the word difference. And this tells me we have a private party, a VIP private party. So who's at that subtracting private party? Well, it's of 6 and a number. So we've got 6 minus a number. And then all of that is divided by 9. Okay, so we have 6 minus a number. Here's our private party. We've got our private party parentheses. And all of that is divided by 9. Okay, so now if I'm going to translate this into algebra, I just want to replace that with a variable. So it's going to look like this. 6 minus x divided by 9 is equal to 5. So 6 minus x divided by 9, right? It says all divided by 9, divided by 9. Okay, so now we're just going to solve this, right? So we have a downstairs Danny down here. Remember, he's kind of a disruptive, little deviant. He's dividing. So we want to get rid of him right away because we can't do anything. He's blocking the door. We can't move these guys. So let's get rid of him. So if he's dividing, the inverse operation would be to multiply both sides by 9. So let's go ahead and do that. So we're going to multiply both sides by 9. And these 9s will cancel. Over here, we don't have anything to cancel the 9, so we have to actually multiply. So 5 times 9 is going to be 45. So we have 6 minus x is equal to 45. And now we want to get x all by itself. So this is not a subtraction. The minus is here, right? This is really an invisible plus. So to get rid of this 6, we need to subtract 6. So these cancel. Whatever you do to one side, you do to the other side. So 45 minus 6 is 39. But we can't leave our answer with a negative variable. We saw that on the previous problem, on problem 2. And so now we have to get rid of that negative by dividing. So we're going to divide by -1. And our final answer, this is a division, not a subtraction. There's a division line there. 39 divided by -1, a positive divided by a negative changes this to a negative. Here we have a negative and a negative. That makes this positive. So our x is positive, but this got changed to a negative. Another way to think of it, when I used to teach middle school, I would tell my students, I would say, okay, take this negative and just throw it overboard. Throw it over to the other side. Throw it over the fence, right? So if I took this negative, this 39 was positive. If I take this and I just throw it over the fence, now this is positive and that becomes negative. Okay, all right, so that's worksheet 1. We're going to do the same thing with interpreting math stories number 2. And I am going to have you do, let me put that worksheet up here. So this is interpreting math stories. I'm going to have you do number 1, 2, and 3 on your own. So I'm going to actually cover these answers up. And I'm going to walk you through number 4, because that one's a little tricky. Okay, so for homework, you're going to have to complete all of these notes, but you're going to have to do numbers 1, 2, and 3 on your own. And I'll do number 4 with you right now. Okay, so on number 4, it says the quotient of a number and 3 is usually means equals 6 less than the product of 10 and that number. Okay, so quotient, that's one of our VIP words. So who's at this VIP party? So quotient of, so it'd be a number. So we need a variable, and 3. So we're going to have a number divided by 3. This is an equal sign, 6, and then here's a special combo, less than, 6 less than, the product, here's a VIP word, so who's at this VIP? So that would be 10 and that number, so whatever number it was up here. Okay, so here we go. Let's see if we can figure this out. It's a lot, Okay, so we've got the quotient. So division, the quotient, there's a private party, a number, and 3. Okay, so we've got the quotient. So here's our, we have an unknown number divided by 3, right? So this is the quotient, is, right, which means equals. And then this says 6 less than. That means we're going to take this 6, we have to move it to the back of the expression, and then the product of 10 and that number. So here's another private party happening, 10 times a number. Okay, so now let's go ahead and clean this up. So we're going to need a variable here, we're going to need a variable here, and we're going to need to put the 6 at the back because this was 6 less than. Okay, so now I'm going to rewrite this. This is kind of the elementary way to write division. So I'm going to rewrite it like we normally would in high school. So x divided by 3, or x over 3, is equal, and then 10x minus 6. Okay. All right, so now we have a variable here. We also have a variable on this side. So we have a variable on both sides. But we really should deal with this downstairs Danny. He's going to cause some problems if we don't deal with him pretty quickly. So remember, he's downstairs Danny is a dividing. So the inverse operation would be to multiply. So I'm going to multiply everything times 3. So I'm multiplying this side by 3. I can't forget, I have to multiply this 10x times 3, and then I have to multiply the negative 6 times 3. So these get canceled out. So I'm just left with x. 3 times 10 is 30x, and then minus 18. So it looks like that. And then we've got an x and a 30x. So we need to get those together, and we need to move this also. So what I'm going to do next, I'm actually going to do 2 steps at the same time. Okay, I'm going to add 18 to both sides, and I'm going to move this x. So I'm going to subtract x and subtract x. So I'm doing 2 steps. We're kind of at a point in the school year where you should be able to handle, handle 2 steps at the same time. So this is a minus 18, so I want to cancel it out by doing a plus 18 and a plus 18. This is an x, I want to subtract an x and subtract an x. So these get canceled, these get canceled. We wind up with 30 minus x is 29. And over here we have 18. Okay, so we have to get x by itself. So a mistake that a lot of you will make is you're going to try and divide by 18. We don't want to do that. We want to divide by 29 so that we can get x all by himself. So we divide by 29, and these will cancel. And we have x by himself, and we have 18 over 29. 18 over 29. Okay, so I have done 5 problems for you. You need to go back, and you're going to need to do problems 1. Let me get there. You're going to need to do problem 1 right there. You're going to need to do problem 2. And you are also going to need to do problem 3 to get full credit. Okay? But make sure that you have work done on all of the problems that I just modeled for you. In fact, you need to have the exact work that I modeled. Okay, so we're getting close. We're getting close to your next test. So I really encourage you to copy it down exactly the way that I modeled it for you for 2 reasons. 1, that will help you better understand how to do it. And 2, I'm not going to give you full credit if you don't copy it exactly as I put it there. So if you leave out steps, just understand that you're going to be forfeiting points. You're not going to get full credit. So don't leave out any steps. Okay. All right. You guys have some fun with that. And I will, I'll see you on our next distance learning episode. Okay. I'll see you guys. Bye.